It says that.
All right, guys, welcome to our very first math webinar. I'm Paula, and this is Michael.
Hi.
Before we get started, please make sure that you can see the chat screen over on the side of the screen. If you're unable to see it, just refresh the page to make sure that it's there. We're going to be using the chat section a lot for us to participate in our webinar. So once you have that figured out, please leave a little comment with your name or just say hi so that we know everybody's ready to go.
Mm-hmm.
That's you.
All right. Our webinar topic for today is teaching strategies, and we are going to be looking at, more specifically, Cathy Fosnot's string model.
So for our icebreaker activity, we're going to begin with the KWL chart. So you guys all have that handout either on Google Docs or on Word Docs. So take the time now to fill out the first two sections of that KWL chart. We know that there is some information about Cathy Fosnot and the string theories attached to the handout, but please only write down what you knew about Fosnot and strings before reading our handout and what you hope to learn from today's webinar.
So we'll give you some time now to fill that out.
Awesome. Bonus points for whoever fills it out the fastest and writes it in the chat.
Yep. Please notify us in chat when you have it done.
Can I write in the chat?
Yeah, sure, go for it.
I don't know where it is.
There it is.
There we go. We can see the chat on my computer screen too.
Okay.
It's too confusing to do on both.
That's no problem.
Let's go, guys. What do you know about the string theory?
Yeah, we'd love to hear it. Because many of you might have already seen this kind of thing in your placement schools or heard about it in other classes or your own research.
It's a very popular method. You might have done it before and not known that it was called the string theory or the string model.
Right.
So when we do it today, you might recognize it more than you thought you did.
Right. Oh, and if you're having any sort of technical difficulties like audio, there's a visual problem, let us know. Oh, the handout is as a Word document on the forums in the Sakai page.
Yeah, if you're going to the Google Doc version of the handout, you have to duplicate it, make your own copies so that you can write in it.
Yeah.
So it's a view only, and then you make a copy of it.
Oh, so James says, not a lot. I worked with strings in my placement as a warm-up for our math classes. Oh, that's
Awesome.
good.
Yeah, I did the same thing in my placement class. It was a good warm-up for students to practice every day.
I had the benefit of, when I was in my placement for Princess Margaret in a grade 7 and 8 split class, we had an expert from the DSBN come in, just sort of our math consultant, I guess, come in, and she did a string exercise with our whole class. And she did pretty much the same method that we're going to showcase today.
Awesome.
Which is why I feel pretty comfortable in doing it. And why I think it's a pretty good method, because I actually got to see it work out with all my students.
Yeah. All right, does anyone else want to share what they knew before this webinar about Cathy Fosnot and the string method?
Yeah, we'll give you a little bit longer before we move on.
Which means? I like that your thing in chat has a little crown.
Yeah.
You're the king.
Yeah, I'm the mod.
Bernadette knew nothing at all. That's okay, Bernadette. We will teach you. No worries.
Also, thanks for showing up, even though you're not an evaluator.
Love to see you here, Bernadette.
Appreciate it.
That's awesome. Have no idea what the string method is. You will find out today, Mohammed. No worries.
Now, Mohammed, I know you were actually in Princess Margaret with me, but I guess you might not have the same person come into your class, or maybe you weren't in for that day. So this will be a good way of catching you up. All right, I think we can probably move on to the next stuff.
Yep. So hopefully you guys have those first two parts of the KWL chart filled out. But if not, we're going to move along anyways. So before we begin, I'm going to share with you a little background info on Cathy Fosnot, who she is and what it is that she does. She's kind of a big deal. So Cathy Fosnot is a leading voice in mathematics education. She's a professor emerita of education at the City College of New York and the founder of Mathematics in the City, a national center for professional development located at the college. She has twice received the Best Writing Award from AERA's Constructivist SIG, and she was the recipient of the Young Scholar Award by the Educational Communication and Technology Journal. She's also the lead author of Context for Learning Mathematics series, as well as the Young Mathematicians at Work series. I actually have a copy of one of her books for the Young Mathematicians at Work series. It's awesome. It's really helpful. There's a ton of activities and just instructional strategies in there. It's a really easy read. She's really easy to follow along with. Also, in 2007, she established New Perspectives on Learning to devote her time to speaking around the world, fostering school change through professional learning and support, and producing new resources and materials. And Cathy Fosnot describes in her resources and in her many talks how modeling the problem in a way that provides applicable context to the children's own life is critical to helping them understand mathematical concepts. And of course, one of the most famous instructional strategies that Fosnot created is the strings model. Of course. We've actually gotten a couple of new comments in while we were just sort of giving them some background on Fosnot here. Let's see here. Rachel Swayze says, not much, just a string of questions to practice. Pretty much, kind of.
Pretty much, except it has more of an emphasis on like mental math strategies, whereas like questions that you practice might, like some people might think of just like, you know, worksheets for that kind of thing.
You're on the right track though, Rachel.
So yeah, very much so. Juliana says, completely new concept for me too. Well, that's good. And Mike Pavella, I used and love strings very much as a minds-on activity. I love the effectiveness of using the money model or the clock model as a real-life application to learning.
Awesome.
Yeah, I actually, one thing that my associate teacher gave me was a big book that I photocopied. It was basically math strings for telling time and money.
Cool.
So really good for younger grades, but as we'll hopefully illustrate, it's kind of just a basic concept that you can really easily integrate with any grade level for math.
Yeah. Do you want to introduce strings?
I will be happy to introduce strings. So what strings are, they are a set of related math problems. They're often used in earlier grades, like I said, but they can be a great exercise for any grade level. Students work to solve these math strings using mental math strategies. So there's very little of students actually trying to write it down or use calculators or what have you. And after all students have, make sure to give them plenty of time. That's like one of the big parts. Big parts about math strings is that they need plenty of think time so that every student should be able to come up with some sort of solution to the problem. And after all students have had their think time and have an answer, they should indicate that they have an answer to the problem. Just using some sort of a small indicator like a thumbs up on the desk is what I've seen a lot of. It's just so that you don't have their hands up in the air putting pressure on every other student to finish faster, which if you've been in school math problems, that might be how you end up feeling. So this kind of activity really helps to show students strategies that they might not have used before and to develop their flexibility in problem solving. A string should be a collection of related problems, ideally, that can help students recognize and use mathematical patterns more efficiently. So hopefully we'll illustrate that with our small demonstration. James even mentioned what you just said. Strings is great for multiple ways of solving problems. Exactly. So that's exactly what the focus of strings is. It's to help students figure out multiple ways of solving math problems. All right, so now that we have a good amount of background knowledge on what Cathy Fosnot's string strategy is, we're going to test it out for ourselves with a string of math problems of our own. So we're going to try to go slowly, but try to type your answers and comments in the chat section quickly so we don't move ahead of your questions. Right. All right. Okay, so you want to use mine? Yeah. All right, here you go. Thank you. So as she writes them down, I'll walk you through them briefly. So let's do our first one here. Thank you, Rachel. Yeah, let us know if you can see this. There's a little bit of glare from the lighting here. So it says 19 times 10. Hopefully everyone can read that. I'll try and use the thicker marker. So just indicate if you have an answer or not in the chat. You don't need to type the answer. Just indicate if you have an answer, and we'll go through some strategies that you might have used to solve it. Try to make it look a little thicker. Oh, that looks good. Yeah? Yeah. Oh, Swayze's got it. She's ready. Yeah, don't write down the answer. Just indicate that you have one, because we'll ask you what kind of answer. Nope, just mental math, Muhammad.
No calculators.
It's online, so we're going to have to use the honor system because we can't see you.
Yeah. No cheaters out there. You think I'm good to write the answer?
A couple more seconds, I think.
Okay. Do you want me to show what my method would have been
Sure.
for this one?
Yeah,
Okay.
I'd be happy to see your method.
Okay. So, as most of you have probably figured out, answer is 190. So one method that I would use or that students might use is they might look at this as 10 times 10 and 9 times 10 grouped together so that we have 100 and we have 90. So add those together for 190.
Basically breaking apart the problem into its place values.
Yep.
If you had any other strategies that you used to solve this, like I know many students, they might not memorize what 19 times 10 is, but they might have memorized what 15 times 10 is, and they basically just work off of that. So if you have any strategies, feel free to share them in chat, and we'll pick them up as they come up.
Are we ready to move on to the next one?
Yeah, so we'll move on to the next question here. The first two, the one we just did and the next one we'll be doing here, are pretty basic, I think, for us for mental math problems, but for your students, they might have more difficulties. So our next one that we have here is 19 times 2.
I like that James used the thumbs up that we mentioned.
Yeah, that's actually really neat. They use the thumbs up emote. I like that.
Yeah. Oh, thanks, Nicolina.
Oh, nice.
She likes my strategy.
It's a good one. That's how I think most students would probably solve it.
Yeah. Such an awkward angle. Oh, we got 2 thumbs up from James. He's ready to move along.
Oh, he's really good then.
Anyone else ready to move along with the 19 times 2? Okay, I'm going to write the answer. I did 20 times 2, subtract 2. Wow, I like that. Okay, so Muhammad did. Oh,
yeah, let's write that out.
20 times 2.
Right.
Which is 40. And then he subtracted 2. So 20 minus 1 twice. So minus 2. You got 38, which is our answer. I like that method a lot.
Yep, James also used the same method as well. It's a really good one.
Awesome.
And of course, some students, when you ask them, like, what kind of strategy did you use for 19 times 2? A lot of them might just say, well, I memorized it or something.
Yep.
So
we could do the same one that we did before, too. You do 10 times 2 and 9 times 2.
Yeah.
Whatever works for you. Are we going to move on to the third one?
Yeah, I think we can move on to the third one. I think everyone did a really good job with this. You guys are so smart.
I'm happy you guys can all see the board as well. Okay.
So this one will build off of the last two really good, I think.
Yeah, I think this really illustrates how a string works.
Yeah, for sure. So for our third problem, we got 19 times 12.
Now, 19 times 12 on its own seems like a daunting question for us to do in our heads. When you look at 19 times 10, which was pretty simple for us, and 19 times 2, which was pretty simple for us, now looking at 19 times 12, it doesn't seem quite so scary.
So again, just let us know when you have it, have an answer and you have a strategy that you use to work through it, because we'd love to illustrate it on the board.
Give us a thumbs up emoji or your strategy.
These guys are so smart.
Geniuses.
James has a thumbs up. Rachel has a thumbs up.
Does anyone want to share your strategy? How did you figure out 19 times 12? Thumbs up from everybody.
Nice.
Love it. Take 190 and 38 and add them. Awesome.
Ooh.
Genius. So if we add these two together, we get our answer.
We get 228, yep.
Yep. 10 plus 2 equals 12. 190 plus 38 equals 228.
Mm-hmm.
Are we ready for the next one?
I think you guys nailed it pretty well. That's some pretty good math. All right.
Equals math, okay. Ready?
So let's try the next one.
Okay.
Again, what might seem like a pretty daunting multiplication question for younger students, it really builds off of previous questions and helps make it a lot easier for them to see patterns and strategies. So again, give thumbs up and list off some strategies that you might use to solve this in the chat.
Any responses?
Rachel and James look good to go.
Mm-hmm.
They're giving us a thumbs up.
So for this one, I might have done 19 times 2 times 10. Because we already know 19 times 2. And multiplying that 38 by 10 is easy for me to do in my head. So that's how I would go about that one.
Oh, you can keep typing out the strategies that you're using to solve these, Muhammad. Go for it.
Got another one locked and loaded. Yep. 19 times 10 plus 19 times 10. I like it.
All right.
19 times 2, then added the 0. That's what I did, Swayze.
Great. These are some really good strategies that we have.
If you have different strategies, let us know. We want to hear all of them. Okay, I'm going to write the answer, but keep throwing out those strategies.
Yeah. And of course, if you have a classroom of somewhere between 20 and 30 students,
this might take a little longer.
This might take a little longer, but I think it's so worth it when you can consider that, like, you might have 20 different strategies that all these students are using to solve these problems.
And it's important that you let every single student have a chance to share their strategy.
Yeah, exactly.
So that everyone can see it from different ways and everyone's strategy is validated.
Yeah. Especially because you can design your strings that you're presenting to your class to focus on specific skills or knowledges that some or even most of your class is struggling with, to really highlight patterns that some of your students who are really getting this kind of problem can express to the whole class and without feeling like they're under pressure.
Are we ready for the next one?
Oh, we have a quick question from Rachel. Did Fosnot state how much time to give students, or is...
It's when everybody's ready.
When everyone's ready.
Everyone needs to have enough think time. So it could take a while.
Yep.
My associate teacher gave the string to students. So she wrote down every single problem that she wanted them to solve and gave them that time at the start of the day while they were getting their agendas out, getting things ready. So they had tons and tons of time, about 20 minutes to do, or 25 minutes to do all of the problems, and then they discussed each one afterwards. So there was lots of think time for them.
Do we want to move on maybe to the... Okay, so we'll do one more question real quick.
This one's tricky.
This one's kind of tricky.
How would I go about this one?
So again, just give an indication when you think you have an answer and feel free to explain your strategy. Now, of course,
I don't want to block it.
Oh yeah. Now, of course, if you're in a classroom and you're working with your students, you would ask them to give you a sign that they're ready and then wait for everyone to be ready and then call on a few students to share strategies.
We left the string up for the whole class and did them at the end. Oh, I like that.
Oh, that's good.
That's really cool. So you sort of had the string up at the side of the room, had them work on it on their own time, and then at the end of the class, you would return to it. So they had time during class to figure it out, hopefully without their calculators. Can the teacher intervene if the students in the class seem to be giving similar answers? Yeah, I think that if sort of one student states their strategy and the rest of the students say, same, that's what I did, the teacher might ask students who are typically saying same.
Give a few prompts and some other strategies, because even if there might be a lot of students who are saying they did the same thing, there might be other students who are saying they did something else.
Yeah,
but
encourage
they
those
just don't feel
different answers.
confident to say it.
Yeah. You could even, depending on the age level, make it a bit of a challenge, saying come up with a strategy that you think nobody else in the class has tried.
Mm-hmm.
So then they're really thinking creatively because they want to be the one to come up with a different answer.
Yeah. So I think we'll put up an answer here and just explain a strategy that some of you might use or some other students might use.
Okay.
So we got 361 as the answer here.
So looking at 19 times 20 and 19 times 19, could we potentially use this previous one to help us find out this new one? Possibly. That would be my strategy. Yeah.
Yeah. Oh, nice, Bernadette. You took 380, subtracting 20, and then just add the 1. Nice.
I like it. That's an awesome one. Cool.
Oh, okay, Jared.
I was 19 times 120. Wow.
I was a little confused. 19 times 20, yeah.
That's awesome.
19 times 20. Subtract
or do
19.
We want to do
Perfect.
one last one?
I think we'll do some recap.
Okay.
Okay.
So let me take a seat here. All right. So now that we've tried all 6 problems and taken a look at some of the strategies that you guys use, we're going to look at some of the most common strategies that students use during string problems.
Now, a lot of you have already highlighted some of these strategies that you've talked about already. So I'll just quickly go through the questions that have used this one most commonly. One of the first ones that we are going to talk about real quick is doubling. Hopefully I'm not tall enough and my head's not cut off from here.
I think it might be.
That's
okay.
Okay. So we'll go over the first one, which is doubling. So that's a solution where, let's just fix this a little bit. I'm too tall. All right, so the first one is doubling, where students can double the solution from 19 times 10 to solve 19 times 20. I don't think that was one that was mentioned very commonly, but that's one that students will probably definitely figure out and make mention of.
Yeah, another one is adding on. So students can add an additional set of 19 to the solution from 19 times 20. If we had done our last one to the solution for 19 times 21, that was going to be our following problem. So just adding on from previous solutions to get your new solutions.
Chunking and the distributory property is really good. So for example, 19 times 19 could be broken into 19 times 10 and 19 times 9. We did this a lot with this one, actually. Paula did a really good example of that.
Okay, and then proportional thinking. So this goes along with the idea of doubling and chunking. So students start to see that when one factor increases by 1, the solution increases by a set of 19. So they start to notice patterns with the problem and how that relates to the solution. Exactly.
So does anyone have any quick questions before we kind of wrap up the stream? You were all excellent.
I like Bernadette's point. My students would round up to friendly numbers and then subtract the difference. So friendly numbers with 10s, 2s, maybe even 5s.
Nice round numbers.
Yeah, numbers that feel familiar to them, that aren't so daunting.
I like that strategy.
I like that strategy a lot, to friendly numbers.
Yeah.
That's cool.
So if you have any questions, you can put them into the chat. And I think we should also take the time to fill out the rest of the KWL chart.
Yeah, so fill in that L section of the KWL chart. Share with the group what you learned today. Something that you didn't know before this, or a strategy that you like that you had not thought of before. Share that with the group and share questions. We'll give you guys 2 or 3 minutes to throw in some questions, throw in some final comments before we wrap up.
Yep.
Thanks, Mike P. You're so nice. It's definitely not the ideal way to present a presentation, so feels good. A webinar showing your future.
Oh, thanks, Rachel.
This week on math. I love it. Okay. You guys were awesome participants.
Thank you so much.
Okay, we'll give you another minute to fill in what you learned. Give us some comments. Just waiting. Also, I have this book with me. If anybody wants to borrow it, it's pretty awesome.
You can probably pick that up in the IRC, I would imagine.
I imagine it's at the IRC. I got it from a colleague of mine. But yeah, you're more than welcome to look through it or check it out at the IRC.
Yeah. So if you really want to do some educational research, look up
Yep.
Cathy Fosnot.
Yeah. She also has a lot of YouTube videos. If you think
Oh,
we're good at doing this
Mm.
in a webinar, Cathy Fosnot kills it in a webinar.
Oh, thanks, James. I hope all the webinars are fun.
I hope they're all as amazing as ours. Just kidding. All right. Okay, I think that we're good. I think we're ready to wrap up.
I think we're looking pretty good.
Okay, I don't know if you guys have to hand in your KWL chart afterwards.
Yeah.
I'm not sure about that. So
Yeah.
keep those on hand. Don't just get rid of them.
Right.
We're not really sure what we have to do with them after this point. So fill in those KWL charts.
Hold
Keep
on
them
to
with you. Yeah.
Don't forget to do the evaluations.
Yeah.
And we won't forget to evaluate all of you.
You guys were all amazing. Thank you so much for showing up.
The compliments help.
Yes, the boost in confidence. It's really great. You guys are wonderful.
Thanks.
Thank you.
If you have any more evaluations that you're going to be doing today or presentations, best of luck.
Yep. Oh, what I learned. Strings need a lot more think time or wait time than I previously had known. Waiting for every student and not just the majority.
Exactly.
It's a very good thing to have learned today.
That's great.
It's very important knowledge for the string model.
Thanks for sharing.
All right.
All right. Thank you, everyone.
Yes, thank you guys.
Bye-bye.
How do we log out?
Have an excellent day. I got it.